Okay. So before I proceed, I request you all to keep pen and paper with you, as I have told you that we will be doing many examples in this. So before we start new topic, let's revise, as 2 weeks have been passed. So let's revise the things. We are doing the chapter of normalization. So I told you, to do normalization, you need to understand functional dependencies, and second, you need to learn which is a key. And then if you are having good command on functional dependencies and key, then you can have mastery on normalization, right? So functional dependency we have already discussed. If you are having functional dependency f from alpha to beta, then what it means? If you are having value of alpha, you can search value of beta, right? It is not compute, right? If you are having value of alpha, then you can search value of beta. That means if you are having roll number, you can search the name. It is something like that. So this was functional dependency. Then we have seen many examples of functional dependency, right? That if you need to see whether the functional dependency is valid or not, let's quickly do one more example. Consider this is a table that you are having with A, B, and C. These are the three columns. And data, let me put some random data: 1, 2, 4. Then, for example, 3, 5, 4. Then, for example, 3, 7, 2. And then, for example, 1, 4, 2. So this is the data table you are having. If I tell you, let me know whether the functional dependency of A to B is valid or not, right? How you are doing, whether value of A, you can search value of B. So A's value 1, you are getting 2. Here 1, you are getting 4. So this is not allowed, right? If you remember, if you are getting 2 at every one, that means at every one you should get 2. Here also, when you are getting 5, here you are getting 7. So this is not valid functional dependency. Let's say BC to A. So at each value of BC, you should get same A. But you can see 2, 4, 5, 4, 7, 2, 4, 2. No value is repeating. So if you want to check, then two values should be repeating, but every value of BC is unique. So 2, 4, 5, 4, 7, 2, 4, 2. So this functional dependency is valid. Then, for example, C to B. C to B. So 4, 2. Here at 4, you are getting 5. So this is not allowed, right? If you are getting 2 at these 4, you should get 4, right? So here also 2, 7, 2, 4. So this is not allowed. Then, for example, CA to B. So each value of CA, 4, 1, 4, 3, 2, 3, 2, 1. So each value of CA is unique: 4, 1, 4, 3, 2, 3, and 2, 1. So no need to check B side. So this is allowed. Last, let's take the last one. A to C. So 1, 4, 3, 4, and 3, 2. So A to C is also not allowed, because here at 1 you are getting 4, here at 1 you are getting 2. So this is not allowed. So this is how you can see whether functional dependency is valid or not. Any doubt, any query in functional dependency? Quick, we don't have time. Any doubt, any query? Okay, good. So second thing that we have seen is closure set. So to find the key, we need to learn closure set. So what is closure set? Let's see. For example, there is a relation R with three attributes A, B, and C, and there are two functional dependency A to B and B to C. A to B and B to C. Then if I tell you, if I am having A, here you can find B, and from B you can find C. So you can say that if I am having A, I can find B and C both, because from A I can find B and from B I can find C. So you can say that from A I can find B and C both. So from that you can see that, see, these are visible functional dependency. This is directly visible, and this is, you can say, indirect functional dependency, that is not directly visible, but from that you can derive that if I am having A, I can find value of B, and if I am having B, I can find value of C. So if I am having A, I can find B and C both. So closure set is nothing but how many attributes you can find from the given attribute. For example, closure of A, this is denoted by this A plus. A plus means A closure. If I tell you what is the closure of A, so obvious thing is that if you are having value of A, you can find A. This is obvious. Then you need to check functional dependency. If I am having value of A, I can find B. So B, and if I am having now I am having B also. So if I am having B, I can find value of C. So I can have C also. So closure of A is ABC, which is entire relation. So you can write like this: closure of A is R. R means entire relation. If you are having value of A, you can find all the attributes of your relation, which is A, B, and C. Now, if I tell you find closure of B, so obviously closure of B, I can find B, and if I am having B, I can find C, but I cannot find A, right? So closure of B is B and C. What is closure of C? Closure of C is obviously C, but from C you can, from the functional dependency you can see I cannot find anything other than C. So closure of C is C. So this is how the closure works. Any doubt, any query on the closure? Anyone? Because now what we are going to do, we are going to do the examples of closure set, right? So let's do the example of closure set. I will give you the relation and functional dependency. We will find the closure set. So let me take the fresh one. So the example is, let's find the closure set of attribute. Consider there is a relationship called R A, B, C, D, E. This is the relation, and few are the functional dependencies. Let me write A to BC, CD to E, B to D, E to A. These are the functional dependency. You need to find closure of B. What is the closure of B? Can you find it? Closure of B. Quick. Closure of B. B and D. B and D, exactly. Yes, very good. Because see, you see from B, we can find B. Then we need to check where is B. This is B. If I am having B, I can find D. So I have used this D. Now from B and D, can I find anything? No. So closure of B is B and D. Very good. Let's do the next thing. There is a functional dependency R, A, B, C, D, E, F, and G. These are the attributes. Functional dependency are A to B, BC to DE, and AEG to G. So this is trivial, right? We have already seen what is trivial. If you are having AEG, you can find G. This is funny, but this is given. Now you find closure of AC. What is the closure of AC? Try this. If you answer A, B, C, D, E, G, B, C, D, E, so many students are giving answer A, B, C, D, E, G, B, C, D, E, A, C, D, E, A, B, C, D, E. Okay, let's see. So if you are having A and C, obviously you can find A and C. Now from A you can find B. So I have used this functional dependency. I can tick mark. So I see that. So I can find B. So if I am having A, B, C, I am having B, C, I can find D and E. So I can find D, E. So I have used this. Now if I having A, E, and G, I can find D, but G. But do I have G? No, I don't have G. So I cannot find G. So this I cannot use. So this is over. Closure of AC is A, B, C, D, and E. So student who are writing G, now you got it? G we cannot find because we don't have G on left hand side. Clear anyone? Everyone? Okay. So let's do, instead of A to B, if A to G, then will be included. A to B. Yes, if it is A to G, then it will be included. Then you can find, but there is not like dependency like.
Sir.
Yes.
Sir, PPT, please. Can you show the PPT? Sir, if A will be directed to G, then can we use BC equals to DE?
No, see, if A is G like this, so from A you can find G. So B will not be there, right? So here it will be G. So you don't have B. So you cannot have D and E both.
Yes, sir. D and E both will be
Ah,
not included.
yeah,
Sir.
and A, E, and G, but then you don't have E. You are having A, you are having G, but you don't have E. So this is also you cannot use. These also you cannot use. Got the point?
So for DE, we need both B and C, right,
B
sir?
and C both. Yes, if you are having B and C both, then only you can find D, not from alone. See, one thing you need to remember. See, if I having functional dependency A, B to C, just a minute. એને ભાઈ એક્ઝામ જ નથી આપી એટલે એ ફેલ છે હા અહીંયા તો ફેલ જ કરવાનું ને હા રિમિડિયલ સાથે ના એકે કમ્પોનન્ટ એને ટૂંકમાં એક્ઝામ જ નથી આપી હા બધામાં ફેલ જ યસ 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 ભલે. So if you are having A, B to C, it doesn't mean that A to C and B to C. No. What it means, if you are having A and B both, then only you can find C. If you are having alone A or alone B, then this is not allowed. This is one thing. But if you are having A to B C, then you can find B and you can find C both individually. What it means, if you are having value of A, I can find B and C. So this is right. If I am having value of A, I can find B. If I have value of A, I can find C. This is right. But here A, B to C means if I am having value of A and B both, then only I can find C. So A to C, B to C is not allowed. Clear everyone? Now? Everyone? Any doubt? Okay. Let's do few more examples so your doubts will get cleared. Let's do one more. For example, R A B C D E F, and functional dependencies are AB to C, BC to AD, then D to E, and CF to B. I want to find closure of AB. Find it. A, B, C, D, A, B, C, D, E. Okay, the right answer is A, B, C, D, E. Let's see. So, if you are having A and B, I am having A, B, So let's take functional dependency. I am having AB. Yes, I am having AB. So from AB I can find C. I can find C. I have used this. So C. Now if I having BC, I can find AD. So BC I am having. Yes, B and C I am having. So I can find AD. So A I already have. I will have D. So these also I have used it. D I am having. Yes, I can find E. I can find E. CF, then B. I am having C, but I don't have F. So these I cannot use. So closure of AB is A, B, C, D, E. Clear? So one last R, A, B, C, D, E, F, G, and H. Then functional dependencies, A to BC, CD to E, E to C, D to AEH, ABH to BD, DH to BC. Now, here the question is you need to check whether BCD to H is valid or not. That means you need to check if you are having BCD, can you find H? If you are having BCD, can you find H? Tell me. I need to, this is something different question. If you are having value of BCD, can you find H? Try it. Yes, yes, yes. But the closure is not given. Yes, but you need to find closure, right? If I need to find whether BCD can find H, then how can I verify that I need to find closure of BCD? If I can find closure of BCD and H is in the closure, then you can say that yes, I am having BCD, then I can find H. So let's find closure of BCD. So BCD's closure is, obviously you can find B, C, and D. Now let's take one by one. If I am having A, I am having A, no. I am having CD, then I can find E. Yes, I am having CD. I can find E. I am having, if I am having E, I can find C, but C I am already having. So I also use this. If I am having D, I can find A, E, H. So A, E, and H. Your question is over right now, right? So if I having BCD, I can find H. So no need to check further because I have not asked to find closure. I have asked that whether BCD can find H. Yes, BCD can find H. So answer is yes. Clear? Clear? Okay. So this is something closer. So now I am going to start the new topic, which is key. So there are many concepts like candidate key, super key, primary key, but first I will discuss key. To avoid the confusion, I will not tell you what is candidate key, what is super key, what is primary key. No, right now only we will discuss key. Little bit we have discussed when we were looking ER diagram and relational model even in the laboratory session, but we will quickly revise, and today we'll see some examples also how to find candidate key. So for us the most important key is candidate key. So we'll find what is candidate key and then we'll see how to find it, candidate key. So let's do it. So our new topic will be types of key. Types of key. So consider there is a table. With 3 columns A, B, and C, and let me put some values. Uh, 1, 2, 3, 4, A, B, C, C, P, Q, Q, R. Consider this is a table R. Now we have already discussed few points that the key are used to search the any value in the table. The key are used to search any value in the table. For example, I want to search this. So to search what I need column and row value. I need column name and row name, but in table column are having name. So you are having which column you are talking about? C. I'm talking about C. But row do not have the name. Row do not have the name. See, column are having name A, B, and C, but row do not have name. So you need a column for which all the values are unique so that I can use it as the key. See, right now I am not telling super key, candidate key, primary key. I want you to first understand the key. So if you see the value, you can see A, every value is unique. If I tell you value of A, can you give me value of B and C? Yes. If I say value of A is 1, you can see value of B is AP. Value of A is 2, value of BC is BQ. Value of 3, CQ. Value of A is 4, CO. So I can tell there is a functional dependency from B A to BC, because if I will tell you value of A, you can definitely search value of B and C. Now, can I tell B to AC or B to C? A, P, B, Q, C, Q, and C R. No. And values are also repeated. See, values are also repeated. So if I tell about key, my value should not be repeated. So B will not alone act as a key. Let's take about C. But C also P, Q, Q, R. So value of C is also repeated. So C cannot work as a key. So can my A work as a key? Now meaning of key is from your key you can find every attributes of your table. So how you can verify whether I can find every attribute? Obviously you can find closure. So closure of A is, from A I can find A, yes. And from A I can find B and I can find C both. So from A you can find A, B and C. So ultimately you can say from A I can find A, B and C. So total relationship is R. So you can find A, B and C. So if my closure is entire relation R, so my A will work as a key. Getting my point? So, but see, alone B and C cannot work. Alone B and C cannot, but can I use it jointly? Can I say BC to A? That means combinedly B and C are unique. Then answer is yes. AP, BQ, CQ, CR. So BC are unique. So APUN1, BQ2, CQ3, CR4. Yes, so I can say BC to A. So can my BC work as a key? Let me find closure. So BC's closure is B, M, C, and from BC I can have A. So my BC can also work as a key. So A and BC are my key. There may be other keys also, but I don't want to go in that direction right now. So A and BC. So I wanted to tell you that there may be multiple keys in your table. There may be multiple keys in your table. And it is not necessary that key contains only one attribute. Here it contains only one attribute, but here it contains multiple attributes. Got my point? So key is the thing from which you can find all attributes of table. Let me give you one more example. If there is a relationship ABCD and there is a functional dependency from A to BC, I want to tell you whether A is my key or not. Whether A is my key or not. So I will find A's closure A. From A I can find BC. Now you can see I can find A, I can find B, I can find C, but I cannot find D. So A is not my key, because if I am having key, I can find every attributes of the table. So the key is the attribute or group of attributes from which you can find all other attributes of your relation. This is the definition of key. Any query up till now? Any query? So now we will go into the detail of primary key, candidate. I want each and every student to please listen carefully. Now I'm going to explain you very important concept, which is candidate key, super key, and primary key. Let's understand this. So consider a relation, just a minute. Consider a relation R, A, B, C, and D. There is a functional dependency A, B, C to D, A, B to C, D, A to B, C, D. These are the functional dependencies which are given. Now let me find the key. Can ABC my key? Let's see. Can ABC my key? So if I find closure of ABC, obviously from ABC I can find A, B, and C. And if I am having ABC, I can find D. So yes, ABC is my key. Can A be my key? So let me find AB's closure. So AB, I can find A and B both. And if I having AB, I can find CD. So yes, AB is also my key. Can A my key? A, this A my key. So if I having A, I can find B, C, and D. So all three are my key. So now let's understand what is super key. So super key is nothing but key. Simple. Super key and keys are synonyms that by whatever attributes you can find all the attributes of the table. So ABC is also super key, BCD is also super key, A is also super key. But now if you observe, so I hope you understood super key. Super key is nothing but from that attribute you can find all the attributes of R, which is definition of key. So all. But now see, the interesting observation you can see, AB is doing the task which can be done, ABC is doing the task which can be done by AB alone. So I don't need C, because from AB I can find all the attributes. And one more thing, from A is doing the task which can be done by AB and ABC both. So it is what it is. It is funny. A can find BCD, AB can find CD, and ABC can find D. What is funny? For example, I am only person. I can find or I can do some task. So what I am telling, give me one more person, we both will do the same task. If I can alone do the same task, why I need second person? So this is, see, here I am the only person, give me two person, we will do the same task. Funny. So now the definition of candidate key. Understand this definition. Candidate key is a super key of which no proper subset is the super key. Candidate key is the super key of which no subset is super key. Now let's see here, which is candidate key. ABC is super key, but ABC is candidate key? No, because subset of ABC is AB and A, who itself are super key. So this is not the candidate key. Let me tell you, AB is the super key, but AB is the candidate key. Answer is no, because AB subset is A. A alone is the super key. So this is also not the candidate key. A is the candidate key, yes, because first of all, subset of A is alone A, and I can find all the attributes. So A is candidate key. So ABC, AB and A are the super key, but ABC subset is AB and A, which itself are super key. So it is not candidate key. AB subset is A, which is itself is super key. So only candidate key is A. So A is the candidate key. And what is the primary key? Or second definition is minimal super key. Candidate key is nothing but minimal super key. And primary key is the key which is chosen by database administrator. So here only one option. So A is super key and A is both primary key. Let me give you some more example so you can understand the concept clear. Consider the relationship R, A, B, C, D, AB to C, C to BD, and D to A. D to A. Now let's see, AB is the super key or not. So AB, I will find closer. So A, B, if I am having AB, I can find C. If I am having C, I can find B and D. B, I am having D. So AB is the super key. C, let's see if C is super key or not. C, I can find C. From C, I can find B and D. From D, I can find A. So A, B, C, D, I will find super key. So B is a super key. Is D super key or not? D closer. So D, from D I cannot find anything. So this is not the super key. So I'm having two super key. One is AB and one is C. Both are super key. Now can anyone tell me which is candidate key? Which is candidate key, AB or C? Which is candidate key, AB or C? C. Why not AB? Why not AB? If you are telling me C, why not AB? What is the definition of candidate key? No proper subset. C is minimal super key. No minimal super key. What it means? No proper subset is super key. See, subset of AB. That means A or B is a super key. No. Neither A nor B are super key. So this is also a candidate key. C is alone. No problem. This is also a candidate key. So AB and C both are candidate key. It means the table may have multiple candidate key, and primary key is anyone chosen by the database administration, whether it can choose AB as a key or it can choose C as a key. That is the primary key. Clear everyone? One more last example to make the concept clear. R, A, B, C, D, B to A, C, D, and A, C, D to B. Tell me the super key and candidate key of this table. 2 minutes. B and ACD are super key and candidate key. Let's see. If I find closure of B, B's closure is obviously B, and from B I can find ACD. So A, B, C, D all attributes which is belongs to R. So this is super key. If I find ACD closure, then A, C, and D, and from ACD I can find B. So it is also R. So this is also super key. And B and ACD no proper subset, are a super key. So both R, B and ACD are super key and primary key. Clear, everyone? So next topic will be finding candidate key. This is very popular in many competitive exams. The questions asked in 1 or 2 marks, find the candidate keys or number of candidate keys from the table. How many candidate keys are there from the table? Candidate, not primary. Primary key is anyone which is chosen by database administrator, but popular question is find number of candidate key. So I want to tell you that if you are free today, this is fresh. Today we have done this. If you are free today, can we do examples from 5 to 6 today, evening 5 to 6? So topic is fresh. So we can do the examples because Friday I need to again revise the thing. So if we do this example today, from Friday we can start normalization. No, always candidate key. See, candidate key is selected by, if you are to select candidate key, but primary key only be one. Primary key only be one. So primary key is selected by the database administrator. So I request you, please, 5 to 6 today, or 5 to 5:30 or 5:45, we can do the example, and these are very interesting example, very easy. If we can do that, I want to start normalization from the next lecture. Yeah, primary key is selected from candidate key. You are right. Yes, primary key is always candidate key, but candidate key may not a primary key. Exactly, Segni. So when we do the more example, you will understand. So today 5 to 6, can we do? Today 5 to 6, because otherwise in next lecture I need to repeat and I need. Okay. So I'm asking your class counselor to generate a link of today's 5 to 6. I may not 5 to 6, but 5 to 5:45. 30-45 minutes I need. So I think it is okay for all of you, right? Today 5 to 5:30 or 5:45. We will do example, very important, and it is being asked in your university exam. It will be definitely asked in your university exam, this question. Find the number of candidate key, very popular question that I want you to do this. So I will ask to your class counselor to generate the link and it will share with you. Any doubt up till now? Should we close this session? Okay.
Sir,
Okay. Yes.
I asked you about the proper subset of, like I didn't get that one.
Proper subset means, see, if your ABC is super key, subset of, what is subset of ABC? Subset of ABC is A, B, C, AB, BC, AC, or an ABC. So any one of these is a super key, then it is not a candidate key. See, now ABC subset is AB. So AB itself is a key. So it is not candidate key. Subset is A. Now AB subset, what is the subset of AB? A, B, and AB. So out of three, is it anything is a key? Yes, A is itself is a key. So it is also not a candidate key. But what is the subset of A? Only A, right? So A is the candidate key. So when you are having super key and subset of that super key himself or itself is a super key, then it is not the candidate key. Simple. Clear?
Okay, got that. Thank you.
Okay. So let's meet at 5 today. Please don't miss that session. We are going to really doing some funny examples and we'll definitely enjoy this thing. I don't know whether you are enjoying learning or this or not, but I am definitely enjoying teaching this to you. So let's meet at 5 today. Thank you all. You can leave now typing your number and we'll meet at 5.